All right, we're going to take just a very beginning look at introduction here to integers and operations, addition and subtraction. So we've talked about integers before. You've probably talked about them many times before. So tell me what you know. What are integers?
Negative numbers.
Negative numbers. Any negative number?
Wholes.
All negative numbers?
Negative.
Okay, so their whole numbers are integers too. So they aren't just negatives even.
All negative.
Okay, so they look something like this when we write them out. For some reason your book is using I, so I'll use it as well. That is not a traditional notation for integers. Most places when you see integers use it's Z, and I think it has to do, I should run this at some point, because I keep saying I think this is true. I think it has to do with the Latin word for integers, having a Z sound to it or whatever. But the integers are actually, sometimes people describe it as the positive and negative whole numbers. But negative whole number actually doesn't even make any sense because whole numbers aren't negative. But they're actually the whole numbers, 0, 1, 2, 3, and so forth, and they're opposites. Okay, so it's actually the whole numbers and their opposites. Or as I just now call their additive inverses. We'll get there in a minute. We're going to look at some different models for integer addition. That's actually where we're going to start today, and that's all we'll get to. Our models for integer addition actually are, the first couple of them, revolve around the idea of having a circular model. And what we do inside of here is we draw chips. Okay, so imagine like poker chips. Okay, so start little circles, right? And there's two different colors of chips. There's either black chips, that's a positive number, or red chips, and that's a negative number. Okay, so this is a positive. And if you don't have red, you can use another color. This one's negative. So if we want to represent the number 5 plus negative 3, we do 5 black chips. We do 3 red chips. And what is the net result of a black chip and a red chip sort of combined?
Cancel.
They cancel at 0, right? If I take a positive chip and a negative chip and I pair them up, they cancel each other out. So I actually cancel out this one and this one and this one. So even though there's 8 chips in there, like Lauren mentioned, they aren't all positive. So this is not the number 8. This is the number 2. Because I pair up these ideas of creating, or one of the ways to think of it is creating a number 0. Positive chip and negative chip, they combine to create the number 0. We'll do one more example because it's so closely related that it seems silly not to. This is the charged fields model. And a charged fields model does the same kind of thing, except that instead of using black and red, it uses plus to represent a positive number. And somebody give me your best guess as to what? Minus. Yeah, a minus to represent a negative number. So what you see is you see the number 5 written as 5 pluses, the number negative 3 written as 3 minuses, and when you pair them up, just like on the previous slide, a plus and a minus cancel, and you're left with 2. It would be plus 2 or a positive 2. If it doesn't have a symbol in front of it, it's understood to be positive 2. Okay? So we will stop there. This, like I told you, is not a long section.